Soil is often called the skin of the earth, yet it is one of the most overlooked natural resources. Every handful of soil supports plant growth, stores water, recycles nutrients, and sustains life above and below the ground. However, across the world, soils are degrading at an alarming rate, threatening food security, ecosystem stability, and climate resilience. Soil degradation refers to the decline in soil quality caused by physical, chemical, and biological processes that reduce its ability to function effectively. One of the major drivers of soil degradation is physical degradation, which includes compaction, erosion, and loss of soil structure. Heavy machinery, overgrazing, and continuous tillage break down soil aggregates and reduce pore space. When soil becomes compacted, water infiltration decreases, roots struggle to grow, and surface runoff increases. This often leads to erosion, where fertile topsoil is carried away by wind or water, removing nutrients that took hundreds of years to accumulate. Chemical degradation is another serious threat to soil health. Excessive use of fertilizers, poor irrigation practices, and industrial pollution can alter soil chemistry. Salinization occurs when salts accumulate in the soil due to improper irrigation or high evaporation, making it difficult for plants to absorb water. Soil acidification, often caused by long-term nitrogen fertilizer use, can reduce nutrient availability and harm beneficial soil organisms. Together, these chemical changes weaken soil productivity and increase crop vulnerability. Biological degradation occurs when soil loses its living component. Healthy soils are teeming with microorganisms, fungi, insects, and plant roots that work together to cycle nutrients and maintain structure. Practices such as monocropping, residue removal, and excessive pesticide use reduce organic matter inputs and disrupt soil biodiversity. When organic matter declines, soils lose their ability to retain water, store carbon, and support plant growth, accelerating degradation further. Human activities play a central role in accelerating soil degradation. Deforestation removes protective vegetation cover, leaving soil exposed to erosion. Rapid urbanization seals soil under concrete, eliminating its natural functions entirely. Climate change intensifies degradation through increased droughts, extreme rainfall, and temperature stress, creating a feedback loop where degraded soils contribute less to climate regulation. The consequences of soil degradation extend far beyond the field. Degraded soils reduce crop yields, increase food insecurity, and raise production costs for farmers. They also contribute to water pollution through sediment and nutrient runoff, degrade biodiversity, and release stored carbon into the atmosphere, worsening climate change. Globally, it is estimated that a significant portion of agricultural land is already degraded, putting future food systems at risk. Despite these challenges, soil degradation is not irreversible. Sustainable soil management practices can restore soil function and resilience. Conservation tillage reduces soil disturbance and protects structure. Cover crops add organic matter, improve aggregation, and protect soil from erosion. Organic amendments, such as compost and manure, enhance soil biology and nutrient retention. Improved irrigation management helps prevent salinity and waterlogging, while diversified cropping systems support soil biodiversity. Technology and innovation are also playing an increasing role in combating soil degradation. Precision agriculture, soil sensors, remote sensing, and data-driven decision tools help farmers manage inputs efficiently and monitor soil conditions in real time. These tools allow targeted interventions that protect soil while maintaining productivity. Ultimately, protecting soil is a shared responsibility. Healthy soils underpin food production, water quality, biodiversity, and climate stability. Soil degradation is not just an agricultural issue, it is an environmental and societal challenge. By adopting sustainable land management practices and valuing soil as a living resource, we can slow degradation, restore damaged soils, and ensure that this critical resource continues to support life for generations to come.